Well, hi guys. We're going to learn how to do integration by parts today, and we're going to practice it tomorrow in class. And we're starting at an advanced integration unit, so we're going to learn 3 or 4 special ways of integrating this unit. AB does not cover this; it's only on the BC test. And so we're going to start with integration by parts. I'm going to show you several examples of them and when to use them. It's a little technical. If you've ever seen the movie Stand and Deliver, it's like a mid-'80s movie. It's about a teacher in really low-income school in California, and his name is Jaime Escalante. He's going to be in this video. Well, not himself, but he actually figured something out that was in that movie that some calculus books have actually embraced. So anyway, we're going to start with this formula. This formula is we're going to have 2 functions of x, u and dv. So if you're trying to integrate and you're going to use integration by parts, you're going to do it when you have 2 distinct functions. This is typically going to be used whenever you have like an exponential and a polynomial, or any transcendental function in a polynomial. So like an inverse trig or a logarithmic with a polynomial, things that you cannot integrate, you're going to use this formula. Once you practice this enough, you'll see you'll be able to see it. But this is our formula here. So the integral of u and dv is equal to uv minus the integral of v du. And there's a lot of u's and v's, and it looks sort of interesting, I guess would be the word. But there's one extra thing I want to teach you, and that is how you're going to choose which function is u and which function is dv. And I want you to remember the word lipet, L-I-P-E-T. Lipet is going to be in order from left to right what you should pick for your u. L stands for logs. I stands for inverse, any inverse function like arctan or whatever. P stands for polynomial. E stands for exponential, and T stands for trig. So if you ever have a logarithm in your integral, you're going to want to have it be your u. That's like your priority. The last thing you want to pick for u is a trig function like sine or cosine. And the next to last thing you want to pick for u is any kind of exponential function. So this is in order. Lipet. Alright, so let's take a look at an example. Alright, we're going to evaluate the integral x times e to the x dx. And I'm going to do a very simple example over here. Something that AB kids can do is if this was like the integral of, say, 2x times e to the x squared dx. This would be a very easy integral for an AB kid to do, because this is of the form the integral of e to the u du. Of course, is e to the u plus c. And the reason this would be easy is because if we let u equal x squared, then what is your du dx? Well, your du dx is 2x, which is right here. So this is a perfect little integral setup. So that answer would simply be e to the x squared plus c, because this extra part is just the derivative of the exponent. But you can see here that if I let u equal x, then the derivative of that is 1, so I've got too much inner derivative here. So this is not something I could do with a simple u substitution. So we're going to go through, this is integration by parts example, and we're going to write down lipet. We're going to look and see. Alright, do we have any logarithms in here? No. Do we have any inverse functions in here? No. Do we have any polynomials? Yes, we do. So this is our choice for u, lipet. So we're going to let u equal x, and the rest of this stuff is going to be your dv. Alright, now here is our formula. The integral of u dv equals uv minus the integral of v du. So to use this formula, I need to find u. Hey, I've got u. I need to find v. I do not have v, but the way I'm going to get v is I'm going to integrate dv to get v. I also don't have my du, but I can get that pretty easy here by taking the derivative. I want you to see how this worked out with the u and the dv. We picked something that is pretty easy to find the derivative of. X is very easy to take the derivative of. So to get du, alright, that du dx is 1. So du is simply dx. And the way I'm going to get v is I'm going to integrate both sides for dv. So v is going to equal, well, what's the integral of e to the x? Well, it's just e to the x. So I integrated dv to get v, and I took the derivative of u to get my du. So my integral of x times e to the x dx is equal to u times v. Here's u, and here's v. So that's x times e to the x minus the integral of v du. So where is my v? Well, there's my v. And what's my du? My du is just dx. Now I realize we put an integral in this formula, but look what has happened. I have turned this into something that I can integrate very easily. So my final answer is x e to the x minus e to the x plus c. And that's what you would get if you were to ask your TI-89 what the integral of this is. Let's do another example. Okay, x cubed natural log of x. Let's write down lipit. Okay, this is what we are going to choose for u. Do we have a logarithm? Yes, we do. So we are going to let u equal the natural log of x, and dv is going to be the rest of the stuff. So dv is x cubed dx. So for my formula, the integral of u dv is equal to u times v minus the integral of v du. So I need to find du. So du dx is 1 over x. That's the derivative of natural log. So du is 1 over x dx. And the way I get v is I integrate dv. So v is 1/4 x to the 4th. So my answer to this is the integral of x cubed natural log of x dx equals u times v. That's the first part of the formula. So natural log of x times 1/4 x to the 4th minus the integral of v du. 1/4 x to the 4th times 1 over x dx. And this will clean up. I can take this x and divide it into the x to the 4th, and that's going to turn it into the integral of 1/4 x cubed dx. So hopefully if I've done this correctly, I create an integral that is easy to do, and this one is very easy to do. So my final answer here is natural log of x times 1/4 x to the 4th minus, that's going to be 1/16 x to the 4th plus c. Okie dokie. Let's see what we got next. Okay, this one is perfect for the Jaime Escalante table. And I'm going to encourage you to use this table version anytime you have you can only use it with the polynomial, so you've got to have an x in it. And especially if you have an x to the 5th. If I were to try to set up my integration by parts, I would have to do this 5 times before I finally got down to the answer. So what we're going to do is we're going to make a little table. And on this table, I'm going to have u. Oh, look at that straight line. And then dv. And I'm going to make my u be, well, with the lipit, what would you make your u be? No logs, no inverse, but there is a polynomial, so it's x to the 5th. Your dv is going to be the other part, so that's sine of x dx. I'll just keep it as sine of x. What you're going to do in this table, and this was actually very ingenious from this teacher, and he taught these kids to do this, is you're going to take your u and you're going to start taking derivatives, because that's what we do with u, until you get down to 0. So let's take the derivatives until that happens. 5x to the 4th, 20x cubed, 60x squared, 120x, and then 120, then 0. Then you are going to integrate dv that same amount of times. The trig function is very easy to integrate, so the integral of sine is negative cosine, and the integral of negative cosine is negative sine, and the integral of negative sine is cosine, and do the integral again, sine, and do the integral again, and do the integral again. Make sure I did that right. Derivative of negative sine is negative cosine, derivative of sine, blah, 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 blah. Okay, yeah. All right, what you're going to do next is you're going to put plus and minuses all the way down, alternating. And then what we're going to do is we're going to multiply down diagonally. And this is going to be our answer. You believe me, if we would have done the formula, this would have taken me 5 pages to do. So, the integral of x to the 5th sine of x dx looks like this. X to the 5th times negative cosine x, we multiply those two. We're going to start with a positive, but since we multiply x to the 5th times negative cosine, that gives me negative x to the 5th cosine x. Then minus 5x to the 4th times negative sine. And when I do minus and negative, that's going to turn it into a positive. So plus 5x to the 4th times sine x. I'm going to run out of room. Okay, so I've done that, and then plus 20x cubed cosine x. And then minus 60x squared sine x. Well, I've run out of room. Just going to have to drop down here a little bit. And then plus 120x times negative cosine is really minus 120x cosine x. And then minus and negative plus 120 sine x. And we're out of terms. And that's how you do the table method. Let's go back and see if I could have done the table method earlier, and just so you can see it again. Yeah, this one's pretty easy. Let's do the integral of x e to the x with the table method and see if we don't get the same thing. Let me extend this page. So if I'm trying to do the integral of x e to the x, then I'm going to let u be my polynomial, and my dv is the rest of the stuff. So if u is x, my dv is e to the x. Take the derivative until you get to 0. The derivative of x is 1, the derivative of 1 is 0. Integrate the same amount of times. Put plus, minus, plus, and we multiply straight down. Let's see if we could have gotten this answer. Is it the same? So it's x times e to the x, there's that, minus 1 times e to the x, there's that, and there's your answer. Oh, plus c. I wonder if I put plus c on my other one. Nope, plus c. Okay, let's do one last example here. Here is 2 transcendental functions together, and we still are going to follow my limit for what to choose for u. No logs, no inverse functions, no polynomials, but there is an exponential e to the x. So I'm going to let u equal e to the x. By the way, you can't use a table method here because you would never get down to a derivative that was 0. Alright, so that means that my dv is cosine x dx. Alright, so the integral of e to the x cosine x dx is going to equal. Alright, so what do I need here? I need my du, which is e to the x dx. And what's my v? What's the integral of cosine? Well, that's sine. Okay, so my integral is uv e to the x sine x minus the integral of v du sine x e to the x dx. Okay, then with the previous examples, once I got to this part right here, I could integrate this side. But look what I have. I have an integral that's just like that one. So I'm going to have to use integration by parts again with this. Again, we would let u equal the e to the x. My dv is sine x dx. So my du is e to the x dx. And my v is what? What's the integral of sine? Well, it's negative cosine. Okay, so let's see here. The integral of e to the x cosine x dx equals e to the x sine x minus, I'm going to put parentheses here because I'm going to use my integration by parts formula. For this, the integral of sine x e to the x is uv. So I've got negative cosine x e to the x minus the integral of v du. Negative cosine x e to the x dx. Sorry, that's getting so messy there. Let's clean up some negatives. E to the x sine x plus e to the x cosine x plus the integral of e to the x cosine x. Are you kidding me? Look what I have in this integral. I am right back where I started. So it looks like I'm going to be going in circles. But notice that I have an equation here that is a true statement. E to the x cosine x dx was my original problem, right? So, I think I've made a sign mistake because this didn't work out correctly. So let's go back here and do some fundamentals here. What did I miss? Because this should be a minus sign. So what did I screw up? Minus all of this. Oh, that negative gets distributed through here. Yes. See, that's why I opened parentheses. Silly Mr. G. This negative goes with this, and it also goes with this. So that means that this should turn into a minus sign. Whew, got a little scared. Anyway, back to this problem. This is a true statement, which means that I can add and subtract both sides. So I'm going to add this integral to both sides. So if I add the integral of e to the x cosine x to both sides, I'm going to get 2 integral of e to the x cosine x dx equals e to the x sine x plus e to the x cosine x. So if 2 of those is equal to that, my answer is all of this divided by 2. Oh, plus c. Anyway, all right, we're going to practice some of this tomorrow, some integration by parts, and so I will see you then.